Hello everyone, we will continue on a new topic today, which is angular momentum. So there are two things. Okay, one is orbital, another one is spinor. There are few parts that is very important over here. For these sessions, we are going to look at these two. This is more or less a recall, and then we are looking at the general formalism of angular momentums. Okay. All right. So what you're going to look at today is the formalism of angular momentums, their definitions, and then this will help you to get ready for solving a three-dimensional problem. Of course, it is particularly useful for studying the dynamics of systems that move under the influence of spherical symmetry. This is the important part, or central potentials for orbital angular momentums of the systems. Okay, and then we are looking at various properties of angular momentum operator. Okay, other operator that we have learned, let me remind you, recall positions, momentums, and you have the energy, and now we are dealing with angular momentum, and the focus on again determining its eigenvalues and eigenstates. So you have somehow commutations, eigenvalue equations that is looking like this. All right, so you have eigenvalue equation. Alright, and then finally we will apply the formalism to determine the eigenvalues, alright, of the angular momentum. Now look at the definitions of angular momentum. We have in classical mechanics, you have in terms of this cross product between the positions and momentum. But of course, when you deal with an operator, you have minus I h bar d over dx. This is respect to x. So if you have x, y, z, your angular momentum is divided into three axes. Okay. So what we're going to do today is we're looking at first, check if your angular momentum is Hermitian. Alright, typo here. So the Hermitian is, remember we choose the dagger. So take one of the example here, angular momentum. So if you dagger your angular momentum, you dagger both sides, but here it's a multiplication. So you change the order. Alright, and then you dagger each of the operator. Remember, momentum and positions are Hermitian, means that py dagger equals to py, so x dagger is just equals to x dagger. Okay, so apply for all momentum and position. So since there are Hermitians, so the dagger is just removed. Of course, we have the relationship such that your p equals to py is 0. Note that your x equals to px, this is 1, or IH bar, similar to py, similar to